here in Cheshire and the sun's shining. It's gorgeous now. I came out about an hour ago and it was really cold, so I put my fleece on for the first time this autumn. And now I'm absolutely boiling. But I'm thinking about hand-eye coordination actually. Hand-eye coordination. And it really comes out of this thinking that I'm doing right now generally about sensorimotor cognition or motor cognition. And specifically hand-eye coordination, because it's a fascinating thing. You know, when you see a ball coming towards you and you catch it, so unproblematically, it's a completely transparent action. But it's a fantastic thing that's happening there. I mean, half the time you don't even need to see your hands when you're doing it. And the ball's coming out of the sky and you've got your hand down here by your chest somewhere or behind you even. And you can just orient yourself, it just drops into your hand. It's amazing that, really, that we can do that kind of thing. And I think what I find amazing about it, well, I find everything amazing about it, but what I find particularly interesting about it is not so much the hand and the eye themselves, although they're fantastic enough, it's the bit in the middle. Because obviously, you know, the eye is a very complex organ, it's very sophisticated, lots of complex mechanisms for adjusting the light input, and very complex photoreceptor cells at the back which do that chemical thing where it turns into a signal to the brain, all that kind of stuff, really, really complex. And the hand is a really complex biomechanical system, again, capable of really, really detailed, fine work with the fingers, and also really kind of large-scale muscular work, very sensitive proprioceptive sensors in the joints, so you can configure it into, you know, really complex shapes. So the hand and the eye are complex, but compared to what's in the middle, I mean, compared to this, whatever that system is that coordinates hand and eye, they're comparatively simple, I think. And I'm not talking about the whole human brain. I mean, obviously that's complicated. But even if it was a relatively simple system, even if the only thing you had was the ability to coordinate a hand and an eye, you know, like those robots that you sometimes get, which have a kind of camera linked up to a mechanical arm. I think those things exist. Maybe I just dreamt it, but I think those things exist. I can certainly imagine them even if they don't. Where there's a camera picking up a signal from the outside world, connected to a mechanical arm that will do something in response to the input. And even if you think about something like that, the bit that's in the middle between the camera and the mechanical arm is incredibly complex. I mean, you call it a computer in that context. And I don't really want to just say that the brain is a computer, because that's kind of obvious, really. It's what else is it? I think that's the best question. But yeah, but that thing in the middle between the camera and the mechanical arm, between the hand and the eye, is going to be so complex that something else seems to inevitably kick in at that point. I don't know what it is, and I don't want to just drop into the language of emergence, but I may have to. But certainly, because, you know, to coordinate a hand with an eye when you catch a ball, it would have to not only make this massive sensory modal transformation from a visual image into a mechanical action. It would also have to transform a two-dimensional image, because one eye sees a two-dimensional image, combine that two-dimensional image with another two-dimensional image to give a sense of depth. You would have to actually see the object, so do all that saccading stuff and focusing stuff. You would have to subtract all of the other movements that's going on, all the movements of your head and the wavings of your body and the walking around that you do, so you can track what's important. And all the time you're doing that, you're also having to mobilize the arm, which is also part of a system, the whole body system, which is also in motion, to coordinate those two events, the visual event and the motor event. Hugely complex. Something that complex, I think, inevitably would be capable of doing other things than just coordinating hands and eyes. In the same way, and again, I know I'm using the computer metaphor, which I didn't really want to. In the same way that if you had a factory machine or a machine in a lab that was capable of coordinating a camera input with a mechanical arm output, the thing that's in the middle, you could probably allow it to serve all kinds of other purposes as well. It would be a computer of some sort. You could probably run a word processing package across it. You could probably allow it to operate some kind of musical instrument. You could probably run some sort of simple traffic control system with it. It would do all kinds of other things, even though its circuitry was primarily engaged in the activities of solving problems, of coordinating hand and eye, camera and the mechanical arm. It's the thing in the middle. Yeah. In other words, you could decouple, I think I'm what I'm saying. I think I'm saying you could decouple the bits at the end. You could decouple the hand and the arm, or you could decouple the camera and the mechanical arm, and the bit in the middle would still have all kinds of uses. Would probably be doing other kinds of jobs actually in any kind of decent system that made good use of its resources.